larva has two different sex alleles. If they are different sex alleles, one having come from the father, the other one coming from the mother, if those two sex alleles are different, it will develop into a normal female, which could become either a worker or a queen. Okay, two different sex alleles, a fertilized egg, the larva coming from that fertilized egg will develop normally. And as we've indicated, can become either a worker or a queen. If the larva has two of the same sex alleles, it will develop into an abnormal male. Say, what? Males don't come from fertilized eggs. We learned way back in the beginning of our beekeeping experiences. Fertilized eggs become workers or queens. Unfertilized eggs become drones. Now I'm telling you, a fertilized egg having the same sex alleles, rather than becoming a worker or a queen, becomes what we call a diploid drone. You think back to your studies of genetics. If you have half of a chromosome set, you are haploid. If you have a double chromosome set, then you're diploid. Di meaning two. So when you have the egg fertilized with the sperm, that is a diploid organism or structure, okay, that ultimately will become an adult. But here, with same sex alleles, you get diploid drones coming from fertilized eggs. When the bees discover a diploid drone larva, they destroy it, they consume it. That's what gives you a spotty fruit pattern, because we'll say half of the larvae are being eaten or destroyed because they're diploid because of this similar sex allele. Diploid drone larvae are eaten by nurse bees when they're less than a day old, leaving an empty cell. Because of this problem with identical sex alleles, it is important that queens mate with drones from different genetic backgrounds. Again, we have no control over it. But the idea is, if we get bees from many different sources, and our bee yards where we're mating our queens are getting drones from all these different sources, as well as the feral colonies in the area, then that's going to increase the probability of them mating with drones that have unlike sex alleles. So, we often think about, especially from a genetic standpoint, we want to select for a particular trait. We want to keep it sane. But what we're saying to you is genetic diversity from the standpoint of mating in the honeybee colony is an important feature, and as I started out talking about that at the beginning. I see I'm getting short on time, so I better jump ahead. Mating just causes a lot of things to change within the queen. It causes her to begin the formation of eggs. It changes her chemical profile or her pheromone profile. It changes her physiology. But we're going to jump ahead now. As I said, a lot of research has been done where virgin queens were compared to when they were mated with a single drone versus 10 drones. Multiple drone inseminated queens elicited a stronger retinue response than single drone inseminations. Again, this has to do with her pheromone profile. How attractive is the queen within the colony. I think we could go so far to say is the more attractive, the larger the retinue of bees that are attracted to her within the brood nest, the better care they're going to provide her. And so what we're saying from this particular study was queens that have been mated with multiple drones are more attractive than queens that have been mated with single drones. As I say, there's a lot of clear, direct benefits of a queen mating with multiple drones. A fully filled spermatheca results in a longer egg-laying lifespan, increases the likelihood of having a sufficient supply of stored semen, and lower probability of inbreeding or this genetic problem that I've just described to you. And you end up with a cosmopolitan type population within the hive. And the more genetically diverse that population within the hive is, the more benefits will be found, which will ultimately end up in a more productive colony. Queens that mate with many drones will ensure that some of her workers will inherit favorable alleles from their father. When they mate with only a single drone, then all the favorable ones that drone has, as well as all the unfavorable ones, will be shared with her. But when you've got multiples, and you look at the population of a whole, those unfavorables will be in a minority within that population because of mating with numerous drones. A queen that mates only with a single drone runs the risk of carrying alleles that are susceptible to a particular disease. Queens that mate with multiple drones ensure at least some of her workers will be resistant to the disease. So it's going to affect diseases, it's going to affect parasites, it's going to affect productivity, it's going to affect comb building. There's many behaviors that's ultimately going to come from multiple matings. Any trait could be impacted by increased genetic diversity within the colony as a result of the queen mating with multiple drones. Beekeepers need to be sure that their queens are properly inseminated with a generous assortment of drone genotypes so that the worker population is similarly variable. So when you're setting up, if you're just raising a few queens, you're probably not going to worry about it. But if you're raising large numbers of queens like Kent or like the commercial beekeepers that maybe raise several thousand queens a year, then ultimately they want to provide mating yards that have a lot of genetic diversity present so that will increase the probability of the queens, the virgin queens mating with a genetic diverse population of drones. So as I said, there's many benefits associated with health and productivity. So there are biological advantages to queens mating with multiple drones, providing a genetically diverse worker force. Can't use the phrase queen mother. Colonies that he's going to produce queens from because of the characteristics of that colony, and so he's going to do his grass from a queen mother. People that are involved in producing large numbers of queens for sale, they also are concerned with drone mothers and providing colonies in the area of their mating yards that are genetically diverse with different drone mothers. In fact, maybe you've read about flooding areas with drones to get better mating. Well, not only are they looking at numbers, but they're also looking at genetic diversity of those drone populations as well. And I'm out of time, and I think I'll stop there.
Question.
Yeah, any questions? Yes.
Is it not possible that if you had a specific genetic or biological disease that you wanted to build up an immunity to, that if you had a particular set of bees that had that immunity, that you could not use just one of those drones to impregnate a queen and thus get a colony of bees that had that disease control built into them?
The answer is yes. Now, for those of you that didn't hear her question, it's rather lengthy. If you have a colony that is, she said, immune or resistant to a particular disease, couldn't you use a single drone from that colony in inseminating queens so that that trait could be passed on to other colonies? And the answer is yes. That's what a bee geneticist does. They have a set of traits in which they want to select for. And they may not start out where there's a colony that's totally immune or resistant to a particular disease, but there may be some evidence that there's some, and so normally this takes several selections, numerous generations to ultimately reach that point. But that's what a bee geneticist does, trying to come up with lines of bees that have more desirable characteristics and are more productive. Yes?
When she puts the sperm with certain eggs, we don't know which one those are. So what is she putting them in there for? For possible queens, for drones, or what?
I'm not sure I follow your question totally.
You said that she uses the sperm sparingly, basically.
Right.
She has to make it last over her lifetime. So the ones that are fertilized compared to the ones that are not, what are they?
Well, in basic biology, it's important that she produces both workers and drones, or male bees. Okay? And in fact, some beekeepers think that the drones, other than just mating with a queen, are an absolute waste. They consume lots of food. They will try to reduce the amount of drone comb in a colony to hopefully suppress drone production in a colony. But biologically, their function is to mate with queens. What we don't understand is that colonies put a tremendous investment in the drone population. Why do they produce so many drones? Well, to increase the probability of successful mating. Tom Seeley, in some of his work, has estimated that only 1 out of every 10,000 drones ever mates with a queen. So why do they put all that energy into producing 999,000 drones? Okay? And we don't know. We don't totally understand it, but it's just to ensure that life goes on.
So what we were told in the class to help kill the beetle population, or no, the mite population, is to put in drug cones.
Right.
So we're just killing our queen. We're wearing out our queen as we say.
The question was using drone comb to help control in varroa mite populations that were wearing out the queen. No, we're not wearing out the queen. Definitely not, because she's laying only unfertilized eggs in that drone comb. Okay? And the reason we're doing it is because varroa mites preferentially select drone larvae over worker larvae for their reproduction. And so we're trying to get them gathered in a single place into 2 or 3 combs, and then we destroy them, and that's how one way of reducing the number of mites within that colony. I think I'm probably out of time. I'm going to be around, and we're going to have a question and answer session at the end of the day. So we'll get some more questions answered at that time. Thank you.